Hello, everyone, and welcome to this, well, I say evening session for the UK and European folks. Hope you've had a good virtual summit day today and also yesterday, and you've learned something new. I know that I have over the last couple of days. I'm joined today in this session by Robert Han. Robert, do you want to introduce yourself?
Yeah, thank you, Rob. I am Robert Han. I'm the VP Global Sales at Entrust for our Centre of Expertise. And that means my team cover specialist areas across our portfolio. My specialism today is post-quantum and preparedness. Thank you, Rob.
Brilliant. Cheers, Robert. And just to round that out, so I'm Rob Dobson. I head up our technology partners here at Device Authority. Work very, very closely, Robert, and the Entrust team around all kinds of subjects, including PKI, PQ, and various other things. And I'm pleased to have you on board here today, Robert.
Thank you.
And for this session, what we're going to be doing, we're going to be talking about exploring PQ, crypto agility, and the future of connectivity, and how that kind of works together, and what the challenges are there. And without further ado, I'll hand the floor over to you for the next 10 or so minutes, Robert.
Well, thank you, Rob. And yeah, absolutely. Our relationship is one of the most exciting ones that I get involved in, because we work in an area that has so many elements of cryptography that need to be managed. And the combination of Entrust and Device Authority is a real 2 + 2 = 5. So let me start with just a high-level summary of Entrust for those that don't know. So we have a very broad portfolio. Our portfolio consists of primarily identity, data protection, and PKI solutions, protecting infrastructures, protecting payment networks, protecting data. That's, I guess, the core. And on here on the slide, we've got all our capabilities presented, many of which combine to solve bigger problems. So when we're talking to banks, we perhaps are talking about digital onboarding, identity, digital signing. When we're talking in IoT areas, we're talking very much about PKI, machines, sometimes custom solutions, code signing, time stamping, keys and secrets management. And as we've shown here, there are so many areas that the Entrust portfolio interacts with Device Authority. I do want to draw attention to the slide title, People and Process. So Entrust also provides advisory services, assessments on how to maintain best practices in the solutions that you have from us and how they fit in ecosystems. It doesn't just have to be Entrust. So we have PKI health checks, we have crypto health checks, but the one I'm going to talk most about today is post-quantum readiness, which is really a journey across so many parts of this landscape. We also position our solutions, I say like many, under a zero trust framework. Zero trust is a way of life. It's not a product, of course it's not. And our solutions support maturity in all of the CISA columns. We adopted the CISA Zero Trust Maturity Framework, which is pretty much the predominant one from what we see across our customer base. But more than just providing capabilities that fit within the columns in combination with Device Authority, we also provide elements that support the visibility, analytics, protection of and orchestration, automation, and as well, of course, governance, which I just touched on when I talked about health checks and assessments and PQ readiness. So it really is a very good fit between Entrust and Device Authority on both measures, the full portfolio, but also from a zero trust maturity perspective. Oh, I forgot this slide builds. We go across and we go up. So our solutions, as I said, are combinations of capabilities that support bigger challenges, cyber hygiene, identity, device management, data encryption, IoT. But we also combine post-quantum readiness with all our solutions, and well, of course, anything that has cryptography in, which is most of our solutions. So by combining PQ readiness and zero trust maturity journeys, there are many overlaps. Better cyber hygiene comes from post-quantum readiness, as it does from zero trust maturity. Better visibility and automation comes from both. Certainly improvements in risk management, governance and planning comes from both. So the combination is really very strong together. So let's just dive into a bit more detail about post-quantum. So quantum computers will break current public key encryption at some point, and the some point is dependent on when quantum computers really hit the mainstream. There are various views on this. Some people are saying it's a generation away, some are saying it's a few years away, some are saying it's around the end of the decade. The accepted kind of perspective is it's around the end of the decade. But there's also an immediate threat, long-term data. Products and solutions, think automotive perhaps, that have built-in classical cryptography, they're going to span, they're going to be out there on the road, they're going to be in the field, they're going to span the quantum transition. So organizations manufacturing those kind of things or dealing with very long-term data like insurance, banking, public sector, really have to start thinking now about post-quantum cryptography, because if data is stolen, it could be hacked, it could be decrypted with quantum computers. And if quantum computers are going to come when Google, Amazon and Microsoft are saying quantum computing as a service by 2028, that's not many years away.
Well, now, so that's a good point. I'll just add something to that, because we work a lot, as we know, in IoT type projects, and all of the projects we work in have a pretty long lifetime. We're not talking like dumb sensors typically. We're talking about vehicles, we're talking about medical equipment, industrial equipment. So when these vendors are looking at their deployments, they're looking at the deployments for a long period of time, not for 1 or 2 years. So in that spanning of that quantum journey, as you talk about, is top of mind for those vendors. So it's an interesting one.
Absolutely is, Rob. And the other challenge to overlay on this is the standards development. So we have the NIST candidate algorithms coming through, 4 candidates last summer. Releasing candidate algorithms isn't enough, because cryptography lives at all layers in the stack, like we talked about automotive, in the chip, in the operating system, in the network, in the application. And standards have to be developed for implementing in a standards and robust way at all these layers in the stack. So all the standards bodies are circling around the NIST competition, starting to release early versions, but that is not quite there yet. Solutions that have embedded crypto, solutions that are security components in ecosystems like hardware security modules, then need third-party certification based on those new algorithms, those new standards. So arguably, we're probably 2 or 3 years away from actually seeing full release of security products, fully PQ ready, PQ resistant, or even PQ safe.
Yep.
So Entrust are working hard to help industry. We work in many of these standards bodies, and in one such standards body is IETF. One of our engineers sits on the working group and has developed what's called a hybrid bridge certificate profile. So we're talking here about PKI, and if you look closely on the right, Mike Ounsworth, my colleague, has put forward, and it's been an adopted draft now, for a certificate profile that is really interesting. It supports classical cryptography, that's what the T stands for in the title, traditional, as well as post-quantum. So you can see, if you look carefully, dilithium and Sphinx. So that enables you to implement post-quantum crypto now, but not turn it on yet. And in complex ecosystems, you have many relying components that have to be interoperable, compatible, supporting something, a connected car or a database full of sensitive data. And so you can, in a more phased way, implement parts of that ecosystem and then switch over when everything's ready. And in fact, BSI, Germany, have said this is the only way to migrate to post-quantum cryptography. And it's really interesting how many advantages it can give, thinking around IoT, Rob.
Mm. Yeah, exactly. Especially you think about the challenge around IoT and the scale and so forth. That's a interesting topic.
So if you implement a new post-quantum ready chip, it needs to support classical because everything around it might not be ready for post-quantum. And so it's a really interesting and useful approach to transition. It also gives you an interesting insurance policy. These are young algorithms. If one of them becomes vulnerable, and it's likely it will, and a couple of them already have, but they need further work, and that's a good thing in cryptography. If one of them becomes vulnerable in 5-10 years' time, you've got a fallback. You could switch to another one of the candidate algorithms without rebuilding, without remanufacturing and everything. It's really,
you're talking about future proofing there, Robert.
Absolutely. So whenever organizations say to me, Robert, how long is it going to take us to be post-quantum ready? My answer is always the same. It depends where you're starting from. And the challenge in cryptography is largely not the technology. It's largely the people and process. It's the out-of-date policies and procedures. It's the trying to retain and develop those specialist crypto resources in your organization. It's trying to keep a handle on workarounds that are happening across the landscape where people are circumventing good practice. They are doing things for efficiency. They may not realize, but they're undermining assurance. So I've got a few problem statements here from various CISOs I've spoken to over the last 10 years. Policies, procedures out of date, crypto resources scarce, best practices often inconvenient, a false assumption that just because we have PKI and crypto that everything's good. Crypto change is actually happening in organizations far more than people realize. We call it crypto agility. So when you inherit a new business application or you implement and choose a different cloud provider, you're inheriting crypto. And there's a whole process around that. You need to check whether it's good crypto, probably is. You need to maybe write new procedures, policies, train people, upskill, reorganize for how you manage this crypto, which is different than you manage that crypto. And organizations really struggle with that crypto agility. And unfortunately, post-quantum is really going to test that skill, that process of change. It's going to happen hundreds, if not thousands of times across a large landscape in the coming years. So let's just summarize as to what are the steps for post-quantum readiness. Well, if you don't know what crypto you've got, you don't know what your risks are, you don't know what you need to change. So number one, absolutely, is an accurate and full cryptographic asset inventory, which you can't just scan for. There are tools out there, Entrust provide these tools, but they can't scan for everything. Crypto's embedded, crypto's enclaved, so you have to have a manual process to capture change as well as this automated inventory. As I've just said, crypto agility is going to be a key skill in organizations in the coming years because of post-quantum. Practice now. It's the recommendation. Get that process down to a really efficient way rather than taking 3 months or 3 years to migrate. Get it down to 3 weeks. And then there's some really interesting quantum-based technologies coming through that you may choose to replace some of the classical cryptography. Instead of moving to PQC, you may actually take one leap further and go to quantum key distribution-based solutions. They're already sometimes in use within military, from what I'm hearing. But you need to balance all of those things with your resources, with your spend, and your day job. because your landscape continues to change and proliferate, and new crypto and everything needs to be managed and risk assessed, etc. So sometime, perhaps in your lunch hour, you're going to be doing post-quantum readiness.
Along with eating as well, right?
So one of those tools I talked about was a crypto discovery tool. This is the one that Entrust provide. It really is the best on the market. It provides a discovery for keys, secrets, protocols, libraries. It hooks into cryptographic sources so that you're able to discover crypto that is not necessarily able to scan. And you can build up a really accurate picture of your crypto landscape and also manually introduce and import other things that can't be scanned for to give you that accurate picture and start to make decisions on. We also provide assessment services I talked about. We have a really sexy name, Cryptographic Centre of Excellence. And those capabilities, those advisory services really help with post-quantum readiness planning. A crypto health check uses that scanning tool, helps you assess what crypto assets you have at all layers in the stack, helps you work out what your priorities are for post-quantum readiness. But equally, it just helps with better cyber hygiene, better cryptographic management. Health checks and around PKI, pretty critical. They should happen more routinely than they really do. Looking at governance around how you manage cryptography is really important, understanding how far you drift from best practice. And that's what these health checks help to uncover. And then finally, we've got our latest one, which is a PQ maturity assessment, which is really designed to help you practice crypto agility. So let's look at that. So we've created from all those checklists and those 20 years of providing advisory services, we've created a scoring system to allow you to measure how mature you are on different metrics across your people, across your processes and technology. So this organization has not yet started asking their critical supply chain from their S-bomb and H-bomb. They haven't started asking, when are we getting that post-quantum ready firmware? Or looking at their DevOps software development and saying, when are you going to start developing for post-quantum crypto rather than just for classical? Or asking their critical supply chains about their readiness plans. Maybe they're holding some of your data and they should be making sure that it's protected against harvest now, decrypt later. Now, when this organization starts to ask their supply chain, they'll start to move up the maturity. And as you can see, there's many factors that are measuring your maturity in terms of cryptographic management and crypto agility, all written here. No organization is going to score 5 out of 5 on the get-go. Excellence on all measures. The point is it's a journey, it's a process. So we come in and assess again, and then we assess again and show that those recommendations of improvements are being enacted. They're being put in place across the organization, and improvements and reductions in risk, therefore, are happening. And of course, crypto agility is getting better and better. Over to you, Rob.
Yeah, so thanks, Robert. And I just wanted to touch on the IoT side of this and how, what Robert was saying about PQ being post-quantum ready and the readiness factor, and what does it mean from an IoT standpoint? And clearly, when we talk about IoT, we talk about various different types of product, whether it's vehicles, diesel engines, smart factories, or medical devices, agriculture, all kinds of stuff. But fundamentally, you need to start with a very strong device identity. In fact, zero trust demands to have that strong identity and being able to authorize devices and so forth. But equally, the challenge there is how do you manage those identities and keys at scale without human intervention? Because as we all know, the number of devices outweighs the typical user based or human centric sort of devices by 50x. So it's really important that we recognize that and have tools to help support that automation phase. But then you throw in the whole concept around having multiple keys or having being post quantum ready. and it throws up another. It kind of like it amplifies the challenge, right? Because you're going to have to provide multiple key sets and perhaps different certificates for each of those different algorithm types. So you've got RSA, you've got the longer AES key types, perhaps, and you've got post quantum when that comes along. So it's going to make that challenge of scale more and more pertinent, and something that needs to be at forefront of people's mind when they're doing an IoT project. But it doesn't stop there, right? So we talk about keys, identities, and so forth. But when we talk about the challenges for IoT and the IT security landscape, there's a number of things here, right? So clearly, yes, you've got that certificate-based identity model on the left-hand side, which is critical for IoT because all of the applications we see rely on, X59 certificates, for example, to connect to the applications and to build that trust. Um, and will post-quantum impact that? Yeah, of course it will, because the things that Robert was talking about only a few minutes ago. End-to-end data security, again, yes. Back to that data privacy model thing again, and harvest now, decrypt later. How do you manage that in the post-quantum world? Will that be an impact? Yes, it will. We talk about identity as a new perimeter here, and clearly, with identity from the point of view of an IoT device, it doesn't sit inside that corporate firewall; it sits outside. Post-quantum readiness is an important factor to that. Applications rely on device trust to make the data valid. We have this saying: if you can't trust the device, you can't trust the data. And it's very true, even when you go through this post-quantum world, right? So going from now until when those algorithms are solidified, it's going to make it interesting to see what happens there. A universal trust method is required to deliver secure updates. Yep, we use standard public key signatures for testing firmware updates and things like that. Clearly, we're going to need to address those in this post-quantum era. And lifecycle management and so forth. And yes, the evolving legislation that's supporting over the next 5 to 10 years in this PQ era is going to be interesting to see how that plays out. But clearly, there's lots going on with NIST and so forth, supporting those activities. So when we work with the likes of Entrust, we we like to think about our solutions, how we can make them future-proof for IoT deployments, as customers choose our solutions to move forwards. So if you go on here, as an example is like on the left-hand side, you've got the IoT devices, whether it's the vehicles, medical devices, whatever. On the right-hand side here, you've got the various IT applications. And then you have in the middle here the Entrust service capabilities, which have the PKI as a service or HSM or PQ services as well. And then we're kind of like you see our products, Keyscape, as a wrapper on top of that. And what you can do by having this solution is make basically embrace this concept of crypto agility and make your IoT deployment future-proofed. And effectively, as new algorithms come out to support different PQ algorithms, and you can support those through the timeline that NIST and CISA are putting out there. And the flows here for this type of, for this example around certificate management, is being able to register on board devices securely, submit CSRs, then through one of our connectors, we reach out to the chosen certificate authority, i.e. maybe PKI as a service, get a certificate signed, and then enroll the device to the chosen IT app, assign a certificate to that, and push the certificate back to the edge device. By having this in place, as I mentioned, you can not only automate the whole thing, but also provide a route to make this your solutions future-proofed as we go through this challenge of being post-quantum ready over the next 5 or so years. So something to think about when you're doing your IoT deployments. And then just to summarize, where we sit with the Entrust guys. I mean, we have, and clearly Entrust have a very well-rounded, strong set of scalable trust services and identity services. I mean, I've just captured a few here: HSM's, PKI service, code signing, and so forth. Combining that with our Keyscaler automation and zero trust for IoT engine, we can then, build out some very interesting solutions and end-to-end solutions to meet the scale of IoT. So we have fully integrated services to Entrust using our connectors. We then have a bunch of pre-built service connectors to all of the well-known ecosystem vendors, so like Azure, AWS IoT, Ericsson, into some vulnerability management tools, PAM, and so forth. And then, once you've got those various components in place, you can then meet any IoT use case or industrial IoT or OT use case, because you kind of join in the dots between the trust capabilities and the automation requirements for those different types of use cases, whether it's medical, automotive, or agriculture, or whatever it needs to be. And as you've seen in the previous slide, is building in that future proofing for this post quantum era, which is going to be important as well. Anyway, I hope that was useful. And Robert, I think I'm going to pass back to you.
Thank you very much. It's quite interesting. The one thing that jumped out at me from you presenting that was device authority's ability to support crypto agility, because it's kind of the management that allows you to say, right, this device, you're going to use this today. I'm now going to squirt new PQ ready firmware down to you, and you're going to start using that. So it fits so nicely with that ability to provide certs, key management, keys, and so on, and of course the kind of stuff you do on device security posture to enable this transition. So let's just summarize. Thank you, Rob. Let's just summarize. So this isn't Entrust saying this. This is the world, the Gartners, the IDCs, Forresters, the professors and the institutes, the standards bodies. They're largely saying this is the journey. With any project, with any program of change, you need a group responsible, accountable, with the ability and the resources to implement the project. Start there. Critically, I didn't mention this, but you need a handle on your data. And the reason you need a clear handle on your data and where your most sensitive data is and what system and ecosystem it fits in is you map that to your crypto inventory, and that gives you a starting point. You obviously will start with the highest risk system first, where I have my greatest challenge. Is it the connected car environment? Is it the consumer database? Is it my healthcare data? Is it my HR records? Whatever it is, that is created, that priority list is created from the combination of crypto asset inventory to an inventory of data and the flows of data. Then have a crypto agility strategy. That just doesn't come about by buying new stuff. As I've talked earlier, it's a process. It involves people, skills, change planning, and so on. But it absolutely does include buying some new solutions. And where we're recommending, and the experts are recommending, is use this breathing space now to modernize and upgrade and consolidate that messy crypto landscape that you've currently got. All those point solutions that are kind of okay, but not integrated, not consolidated. Use the time now to consolidate. Bring in that ultra modern IoT security lifecycle management system from Device Authority. Bring in that hybrid bridge supporting PKI from Entrust. Bring in that X, Y, and Z from all the other parts of your ecosystem. Use the breathing space now to make the journey simpler, smoother, and allow you to be more crypto agile in days or even minutes rather than months or years. Then test and migrate. Of course, that has to happen. It's all about incompatibility. It's all about testing and everything. And then as we pop out the other side, when quantum computers are here, we're going to have much better cryptographic management, much simpler and more consolidated solutions, much more capable with that built-in crypto agility. And we'll just be better at crypto management because a focus has been put on it for the last few years. And just after that, world peace will follow.
Hopefully.
Thank you.
Brilliant. Thank you, Robert. And I think we've got one or two questions here, maybe one question or point. Actually, somebody was mentioning that add to that the different secure device deployment technologies across all the semiconductor manufacturers. There is no standardized process in how secure devices are onboarded and then deployed into products across all the device manufacturers. It's an interesting one, and one which there has been some effort actually by a number of standardized bodies like FIDO, FIDO Device Onboarding Group, to try and address that challenge of, how do we standardize the onboarding process? And that is one area which it does still need to take some adoption, because it is still a diverse set of standard onboarding type of processes. But that is coming. So FIDO is the FIDO 1.1 spec is out there, so I'd encourage you to look at that as well. I don't think there's anything else. Robert, are you still online?
I am still here.
Okay,
absolutely. I've lost my camera, unfortunately.
Well, no worries.
But I'm here.
It's the lack
I'm
of
here
VQ
in
readiness.
spirit. Well, that's right.
Yeah. Okay, perfect. Well, I don't think there's any other questions, but if you do want to reach out to us, either myself or Robert, feel free to. In fact, you can just scan the QR code there on our screens right now and reach out to us on LinkedIn. Happy to have a chat about your post-quantum readiness, and any other discussion around IoT. Happy to take that as well. Otherwise, I would like to just thank Robert for his contribution and for attending this session with myself. And hope everyone has enjoyable rest of their day and evenings.
Thank you very much, Rob, and thank you everyone for listening.
Thank you. Bye-bye.
Thank you. Bye-bye.